and 11.6. First, please check your answers to 11.5. Feel free to email me or class comment on any questions you have about the answers to 11.5. I know you didn't have to graph them, but this is what the graphs would look like. All right, today we're going to practice simplifying radicals. A radical expression contains a radical symbol. There are many different types of radical expressions. For our purposes, we're only going to use square root symbols. The expression under a radical sign is the radicand. All right, we want to have no perfect square factors that go into the radicand. We want the radicand with no fractions, and we want no square roots in the bottom of a fraction. This paragraph, don't worry too much about this in Algebra 1. We're going to assume all variables represent non-negative numbers. All right, so perfect squares. You need to become very familiar with these. The perfect squares 1, 4, 9, 16, 25, those numbers are going to be really important for helping us simplify radicals. I also wanted to remind you that we know the square roots of all even-powered variables. All right, so my first example, whenever possible, reduce the fraction before simplifying. I know that I can divide out a factor of 2, which leaves me with the square root of 1 over 25. We studied this previously. You can just take the square root of the numerator and the square root of the denominator, and we would be left with 1/5 as my answer. For question B, we're just going to evaluate using order of operations. 8 squared is 64, 15 squared is 225, the sum is 289, and 289 is a perfect square, it's 17. If you had a calculator, you could type in second x squared 289, enter, and it would tell you it's 17. For C, this is a perfect square trinomial. If you remember, we can factor that as x minus 3 quantity squared. When you take the square root of something squared, you're simply left with that original expression. For D, these numbers actually are divisible. 4 goes into 256 64 times, and I know the square root of 64 is 8. For E, we're going to add the two numbers up first. The square root of 49 is 7. All right, we're going to take the square root of something squared, and we're just left with 3 minus x. For G, I'm going to factor this perfect square trinomial as x plus 3 quantity squared. I take the square root of that value squared, and I'm left with x plus 3. For H, following order of operations, 100 minus 19 leaves you with the square root of 81, which is 9. For I, 72 minus 8 is the square root of 64, which is 8. And for J, you end up with the square root of 25 plus 144, or the square root of 169, which is a perfect square and leaves you with 13. Now, sometimes things don't always work out perfectly like that. What we're going to try to do is find a perfect square factor. Remember those 4, 9, 16, 25, all those numbers, 36, 49. One of these numbers needs to go into 24. And I know that 4 does. So I'm going to break up the square root of 24 into root 4 and root 6. The whole purpose is that I know the square root of 4 is 2, so that comes out with no radical over it. And I don't know the square root of 6. The reason we cannot break down 6 is 6 is not divisible by one of my perfect squares. At least one number on my perfect square list has to go into the number under the square root symbol. For 300, the largest perfect square that would work would be 100. Root 100 times root 3. The square root of 100 is 10, and I leave the root 3. Now I know 25 might work, but we want the largest perfect square possible, 10 in this case. So for 72, before you all start guessing that 9 would work, there's a larger perfect square that will go into 72, and that is 36. The square root of 36 is 6, and you're left with 6 root 2. For those of you that said, hey, I really want to deal with the 9 and 8, you can, but it's going to take you multiple steps, because at this point, 8 can continue to be broken up. What perfect square goes into 8? 4. So I would have 3 times root 4 times root 2, or 3 times 2 root 2, which is 6 root 2. That is a lot more work. Please take take a minute to find the largest perfect square, trust me. For 90, I can break this up into root 9 and root 10, which leaves you with 3 root 10. Let's keep practicing. 128. Use your calculator to divide. Believe it or not, 64 times 2 will get you 128. So the square root of 64 is 8, and you leave the root 2. For this example, I know the square root of b squared is b, and I know the square root of c squared is c. So you're just left with bc. All right, an odd-powered variable. That's always a problem. We want to break it up into something times x. So x to the second power times x would work. The reason we want to do that is that the square root of this even power, the square root of x squared is x. The square root of y to the fourth is y squared. The only thing I don't know how to deal with is that square root of x. So your answer would be xy squared root x. For 98, I can break that up into 49, root 49 and root 2. Root x cannot be broken up, and I know the square root of y squared. So the square root of 49 is 7, the square root of y squared is y. Those two come out in front, and you're left with root 2x under the square root symbol. Here's another odd-powered variable. Oh no. So I want to break it up into something times x, which in this case would be x squared again. So I know the square root of x squared is x, I know the square root of y squared is y, and I'm left with root x. So xy root x. All right, 48, let's use root 16 and root 3, root a squared and root b. I know the square root of 16 is 4, I know the square root of a squared is a, and I have root 3b that I can't do anything else with. All right, fractions. In this case, let's just apply the square root of 5 and the square root of 4. When I do that, there's not much I can do with root 5, but I do know the square root of 4 is 2, and that's how I would leave my fraction. For b, I strongly recommend simplifying first. So let's divide out an m from the top and the bottom. That will leave me with the square root of m squared over 9, and now I know the square root of both. The square root of m squared is m, and the square root of 9 is 3. All right, this will be the last set of examples, and then we'll finish this classwork tomorrow. All right, the square root of 36, we already know that, it's 6, and the square root of x to the fourth is x squared. For d, I'm first going to divide out 3 from both. So my new problem says root 4 over root 9, and believe it or not, I know the square root of both of those. For e, I know the square root of 1 is 1, and the square root of 100 is 10. For f, I know the square root of 121, and now I need to break up x to the fifth into something times x. That means I'd be with root x to the fourth times root x. So after you simplify all this, the square root of 121 is 11, the square root of x to the fourth is x squared, the root x must stay, and that's all over 3. That was our most complicated example. For g, let's break up the numerator into root x squared and root x. The denominator is already a perfect square. I know the square root of x squared is x, and I don't know anything else to do with this root x, and that's all over y. For h, I can't really break up 21, but I do know the square root of b squared is b. The bottom, I know the square root of the whole thing. The square root of 25 is 5. The square root of c to the fourth is c squared. All right, hope this helps. We'll do this lesson again tomorrow with the rest of your classwork packet.